Okay, today we're trying to find the area under the curve. We have example number 1. We want to find the area of the curve and between the curve and the x-axis, between the two x values, which are the limits. So we have 3x minus 5, and the first x value is 2, and the other one is 6. So with the given f of x and the given limits, we need to write this in integral notation. So we got to remember that integral means area under the curve with the limits of 2 to 6. So we're going to put the limit. We're going to write the limit on the bottom 2 and then 6. Okay, and then we're going to write the equation 3x minus 5 of d of x. Okay, and then so now that means that we're going to find the area under the curve. But we do the antiderivative of this, and our limits are going to still stay at 2 to 6. So we're going to have to write this in terms of equal. This is equal to, the limits stay the same, 2 to 6. Now, we take the derivative of 3 of x. What we need to do is raise the power to 2, and that's going to be the divisor of the coefficient that was there before. So that's going to be 3 over 2. That's how you take the antiderivative of a term. Okay, the next one is going to be minus 5. So minus 5 does not have an x, so it's kind of like having x to the 0. So we increase x to the 0 to become 1. So we have 5x to the 1, or just 5x. And the divisor of 5 would be 1, which would just simply be 5. So this is describing the area under the curve. Now we have to write them separating the two limits. So the upper limit needs to be written first. That's going to be 3 over parentheses 6 squared minus 5 times 6. And then we subtract the other area, which comes from the lower limit. And that's going to be 3 over 2 parentheses 2 squared minus 5 times 2. Okay? Doing the math here, we're going to have to subtract that section. Okay, so we do the math here, and that's going to be, 6 squared? And so that's going to become 3 over 2 times 36 minus 30 minus 3 over 2, 4, because 2 squared is 4, and 5 times 2 is 10. So now 2 and 36, we can reduce that and make that 18. So that makes 36 18. Okay, and then 18 times 3 is what? 54. So that's going to be minus 30 minus, okay, so then that's 2 goes into 4 2 times. So 3 times 2 is 6. 6 minus 10, okay, is equal to, so we have 54 minus 30 is 24 minus parentheses 6 minus 10 is negative 4. So that's going to be 24 plus 4, which is 28. So the answer is 28 square units. And here they didn't indicate the units, so that's going to be 28. Okay, so those are all the steps that we have to do for this problem. Example number 2. We still need to find the curve between under the curve and between the x-axis and the curve, right? So the x values are 2 and 4 this time. So we have f of x is equal to x squared plus x. And so we need to write it in, again, in integral notations with the limits on there. So we're going to write 2 at the bottom, 4 at the top, and we have x squared plus x, okay, is equal of d of x, okay. So then we take the antiderivative of this, or the integral of that, and so the limits stay 2 to 4, and we have x squared. So that's going to increase the x squared to a 3, and that's going to be the divisor over 3. I mean the coefficient over 3, which is 1 over 3. And then we have a plus, and we have an x, which is, we're going to increase it to 2, so we have to put 1 over 2 there. And that's going to be our antiderivative. And now we compute by inputting the limits. So we start off by putting the upper limit, which is 4. So we're going to write 1/3, 4 squared, 4 to the third, and 1/2 times 4 squared, minus 1/3, 2 to the third, plus 1/2, 2 squared. Okay, so the 4 to the third is what? 4 times 4 times 4. So let's go ahead and do it over here. 4 times 4 is 16. Times 4 is 24. So that's 64. So 64 divided by 3 is that. Then we can erase this. And then we have 4 squared, which is 16. 16 divided by 2. And that's going to become 8, but we'll work with that in a little bit. So then we have 1/3, and 2 to the third is 8. So then we can write, we're going to be able to write this as 8 over 3. Then we have 1/2, 2 to the 2. So 2 to the 2 is 4. Okay, so then we have 64 over 3, and we have 16 divided by 2 is 8. Okay, and we can't divide 64 by 3, so we leave it like that. Minus 8 over 3, and then plus 4 over 2, which is 2. Okay, then now we want to try to combine everything and leave it in a fraction. So we're going to write 64 over 3, 8 over 1, minus parentheses 8 over 3 plus 2 over 1. So the common denominator between all 4 of them is actually 6. So we're going to write 64. Oh, it's actually 3. So we write 3 on the bottom here. So 1 times 3 is 3. 8 times 3 is 24. And then 8 over 3. And then 1 times 3 is 3. So 2 times 3 is 6. 64 plus 24 is 88 over 3. And then this is going to be minus what? 8 plus 6, which is 14 over 3. Which ends up being 84 minus 14 is 74 over 3. And this is going to be area, which is square units. And that's the process of finding the area under the curve for this problem. Okay, next what we're going to do is we're going to find these same values with a calculator. So we'll look at that right now. Now, remember, that example 1, the answer was 28. And example 2, the answer was 74 over 3. Okay, well, so what we need to do to show you how to find the value using a calculator, we bring out the calculator and we enter into y equal, we enter the function 3x minus 5 for example 1. Okay, we graph it and it's a straight line, but we need to to be able to, we can compute it using the calculator. So we go to second calculate, which is second trace, and we pick the value of 7. So we pick the value 7, and then the limits are from 2 to 6, so we enter 2, enter, and then 6, enter. And then once we press enter, it gives us the value, which is going to be 28. Okay, now and we can check that it's correct. So now to enter example 2, we enter the equation x squared plus x. We graph it, and that's going to look like a quadratic. There's a little bit of delay here with the calculators, but you saw quadratic. Now the limits are from 2 to 4. So we enter 2, enter, and then 4, enter, and we get the value of, we get a decimal value. We're going to get a decimal value right now. There's a little delay, but that's the value. But if we divide 74 divided by 3, guess what? We get the same decimal value. So yes, they are the correct